Hey everyone, today we are cracking set 2, question 4, testing if a 4-week fitness program actually boosts students' energy level using a paired sample t-test.
So, here is the situation. We measure the energy level of 10 students before and after joining a 4-week fitness program. We are using a pair T test because it is the same students tested twice. Basically, we want to see if the after score are really highest, not just random differences. As we can see from the table, uh, about the first student before went to the fitness program, the energy level of the student is around level 5. But right after he went through the fitness program, the energy level increased by 6 by once one level.
So let's set up with our hypothesis. The null hypothesis, H null, says there's no difference in energy levels, but the alternative H1 says there is a difference. The program actually works. It means that the program actually works. We will test this at a 1% significance level. That's quite straight, meaning the evidence must be really strong to reject H null.
So, for the calculations, after we list all of the things that we got from the question, we're going to get a table just like this. And then we need to find the difference, which is the difference. And how are we going to get that is we're going to take the after and we're going to minus it with before. As an example, 55 minus with 50 and we're going to get 5. So how to get a sum is we're going to sum all of the difference that we got from participant 1 till participant 10, and then we're going to get 37. And the n for this question is 10. It is because that the things that there's only 10% involved in this question. So we're going to go through with how are we going to get the mean difference. So mean difference equals to sum of d over n. So we need to put all of the things that we got, and we're going to get 37 over 10, which is equals to 3.7. So how are we going to get the standard deviation of difference? So standard deviation of difference as d equals to square root sum of di minus min d square over n minus 1. So that's just the formula. So we're going to go through with how to use the first formula in the next slide. So we're going to go through with how to get the standard deviation for the difference. So we all know that the formula have the sum of di minus with min d square. So you guys must be confused to how to get this. So just list all of the things that we got, and uh, to make it easier to count, list all of it, and then I think you guys must be confused. Why and where did this di comes from? So the di is the after minus with before earlier that we did. So basically the di is the difference. Yeah, the di is the difference. So list all the difference and list all of the difference minus with 3.7 and list all of the difference minus with 3.7 squared. You guys could do this without listing it one by one. I mean, like, do it. You guys could do it. If you guys understand it, already know the concept and how to calculate this, you guys could just go and count it. Just list the difference minus with 3.7 square. So we're going to sum it and we're going to get 12.1. So after we get the 12.1, just put it in the formula and we're going to get SD equals to square root 12.1 over 9 and calculate it, we're going to get 1.1595. So going through with step C, which is the t statistic, so we're going to use the formula t equals to d min, which is the mean d, over standard deviation of difference over square root 10, which is square root n. Sorry, I mixed it up. But yeah, we have all the things that we got. So we just put it all in the formula, and we're going to have t equals to 3.7 over 1.1595 over square root 10. So solve it, and we're going to get the 10.09. So going through with the step D, which is degrees of freedom and critical value. So degrees of freedom, which is df, equals to n minus 1, which is 9. So the two-tailed test at alpha equals to 0.01, uh, and the critical region, which is degrees of freedom equals to 9, equals to 3.25. So for the last step, which is step E, for the comparison and the decision. So as we know, the T calculation that we got earlier is 10.09 are more than the critical region that we got, which is 3.25. So the answer is we're going to reject the hash null because p value is extremely small, so the result is highly significant. That's all.